Well, this is Scholar Trash doing some math. So today in geometry, so previously we learned about SSS, SAS, HL, AAS, ASA. So these are all the ways that we can show triangles are congruent. Okay. Once we've shown that they're congruent, we can say that congruent parts of corresponding parts of congruent triangles are congruent. And that's where the CPCTC comes from. Excuse me. This is something you should remember, that corresponding parts of congruent triangles are congruent. So if you have two triangles that are congruent, then you can say, well, these two sides are congruent because they're corresponding sides. Like in example 1 here, what we're trying to do is show that the two triangles are congruent, thus making these two sides congruent. So let's do that. So they give us AB is congruent to DE, and angles 1 and 2 are congruent. So in order to show that the top triangle is congruent to the bottom triangle, we need some more information, and we need more congruent stuff. So here we go. Let's look at these two central angles here. So they said angle 1 is congruent to angle 2, and then that angle. These angles are across the intersection, so those are vertical angles, and what's special about them is that they're congruent. So angle ACB is congruent to angle DCE, vertical angles. Okay, so we just need one more piece, and it probably has to do with those exterior angles, angles 1 and 2. Now, if we notice, angle ABC, here, let's do this in red. Okay, so angle ABC next to 1 and angle 1 are supplementary. And same thing with angle 2 and angle DEC are supplementary. Okay. Since angle 1 and 2 are the same, that means angle ABC and angle DEC are congruent. And that's by the congruent supplements theorem. If two things are supplementary to the same angle, then those angles are the same. So now we have that the two triangles are congruent by angle side. So two angles in the non-included side. Okay. And then by CPCTC, these two sides are congruent. Alright, example 2. Use congruent triangles to find the distance between two dock boats A and B. Okay. Let's see here. So use congruent triangles to find the distance between two dock boats. Two docked boats. Okay, so I was looking at this example, and basically, so we have two boats, A and B, and they want to know the distance between the two boats. Okay, so they're looking for AB. But you, well, it's kind of weird because so you can't, for some reason, you can't swim and just measure out in the water. So you walk along BC here, or you start at B and then you measure the distance. So what you're going to do is you're going to use the land to create two congruent triangles. And so you walk perpendicular to B, forming a right angle, and you walk a certain amount of distance all the way to D. And you make sure that the distance between D and C and B and C are the same. Okay? And then you just walk a certain distance to E. Okay, I'll put down the steps. Sorry. Put a mark at D. So that AB is perpendicular to BD. Okay. Step 2, we'll find the midpoint of BD and call that point C. So find a point E that DE is perpendicular to BD and points ACE are collinear. So basically you have these two triangles by angle side angle. The two triangles are the same, therefore these distance, so all you have to do is measure from D to E in order to get the distance from A to B. And does it matter how far away from point B that you mark point D? No. So basically what's going on here, you're trying to find the distance between two boats and you can't swim. Point B, boat B though, is connected to land, and if you if you walk a certain distance perpendicular to it and just mark some random point D, and then walk perpendicular to point E so that it lines up with the boat A and the midpoint there. All you have to do is measure the distance from D to E in order to get the length of the boat AB. Not a fan of this example. There's easier ways, like if you wanted to find I prefer the example where you're trying to find the gap in a canyon or a cliff. You know, there's no bridge, so you can't measure it. But anyways, let's move on. Checkpoint 1, explain how to prove PR is congruent to QS. Okay. So we have this angle here, congruent to that angle, and this side is congruent to that side. Okay. So we know that these angles are congruent because those are vertical angles. So now we have angle side, which shows that the two triangles are congruent. So let's write that out. So we know, so they gave us that, so ST is congruent to RT, and they also gave us angle TPS is congruent to angle TQR, and these were given to us. We know that angle PTS is congruent to angle QTR because of vertical angles. Okay. So we know that triangle PTS is congruent to triangle QTR because of angle side. And now we know what that is. We know that PT is congruent to QT because of CP, congruent parts of congruent triangles are congruent. Okay, so first we had to show that the two triangles are congruent. Now we show that this piece here is congruent to that piece, or that piece. Okay, and now we can combine. So PT plus TR is equal to PR. Same thing. QT plus TS is equal to QS. And we're allowed to do that because of the segment addition postulate. Okay. And now finally, through substitution, since TS is the same as TR, PT adding TR is the same as PT adding, or same thing as QT adding TS. So since those are the same lengths, those are congruent. Alright. First, use the information given to prove triangle bed is congruent to triangle SED, CED. Then use those congruent triangles to prove that triangle ABD is congruent to triangle ACD. Alright, here we go. Statement. Reason. 1. So they first want to prove triangle bed. So the bottom left triangle is congruent to the bottom right triangle. Okay, here we go. Angle 1 is congruent to angle 2. So first thing we need to do is do all our given. And I'm going to save some space. So angle 3 and angle 4. That was given as well. Okay. 2. Angle 1 is supplementary to angle BDE because linear pair definition. 3. Angle 2 is supplementary to angle CDE. Same as 2. Okay, so what we're doing here is angle 1 is supplementary to BDE, so this angle here, that's what we're doing here. And angle 2, so those two angles are supplementary, and since angles 1 and 2 are the same, that means angle BDE is congruent to angle CDE. And that's by the congruent supplements theorem. If two angles are supplementary to the same angle, then they're congruent. 5. Okay, so we got this angle now. 3. Okay, we have angle, angle, and they both share DE here. So DE is congruent to DE. How do we show that? That's through reflexive property. Okay, now we have all the pieces to show triangle bed is congruent to triangle CED. And that is through angle, angle, side. Okay, now that we have that, we can now say that BD is congruent to CD, because since those two triangles are congruent parts of congruent triangles are congruent. Okay, so let me put this in a different color here. So this is red. So those pieces are now congruent, and we have an angle, and now they both share this. So AD is congruent to AD. That's through the reflexive property. And now I have this. This would go on the bottom, and then you would say triangle ABD is congruent to triangle ACD. Why? Because we have side, angle, side. All right, let's do another one. GH is congruent to KJ. FG is congruent to LK. There's a lot going on in this picture. So they already marked everything. Triangle FJK. FJK, so we want this triangle congruent to this triangle. Okay. So here we go. So these would be given. So statement, reason, you would put all this here, and then you would put this here. 2. Okay. Alright, here we go. I'm going to say HJ is congruent to HJ. Because I can. But no, what I'm trying to do is... here, I'll show you. HK is congruent to JG. So HK is congruent to JG. And that's through segment addition. They're both adding the same thing since HG. So think of the two red lines here. So KJ and HG. If they both add the black line, then they're the same. And so those are the same, I can finally say that these two big triangles, let's see if I can use color here. So FJG, so the blue triangles are the same. Okay. So triangle FJG is congruent to triangle LHK. And why? Because we have a right angle here, and now we have two sides of congruent. So this is HL postulate. Because we have right triangles, the hypotenuses by that double tick mark, and then we just showed that one of the legs are congruent. KH and GJ. Okay, now that we have that, we can say that we can say that FJ is congruent to HL by CPCTC. So I'm talking about this one here and that one. Okay. And then, to put the rest on here, sadly, maybe. So 6. So we're looking at this angle here and that angle here. Angle FJK is congruent to angle LHG. So because those two angles, so if we look at the right angle and the angle next to it, we know those add up to a straight line, which is 180. Therefore, they have to be right angles. And because those are right angles, these two angles are congruent. So right angles are congruent. Okay, and now we have side angle side. Triangle FJK is congruent to triangle LHG. Whew. So we have side, angle, side. So side they gave us in the beginning, angle that we found, the other right angle, and then the side. So SAS. That was rough. And you know what? We're gonna go with, we're just gonna skip example 3 and say good enough for today. Have a good one.